Dr. Gonzalo Rado. Gonzalo is a senior principal engineer with Wood Incorporated. His presentation today is based on the outcomes of NCHRP Project 1433, pavement preservation, or pavement performance measures that consider the contributions of pavement preservation treatments.
Thank you, John, and a very good afternoon to all of you. I am delighted to be here today, and I appreciate the opportunity to give this presentation on NCHRP Report 858, just got it about 3 days ago, which is titled Quantifying the Effects of Preservation Treatments on Pavement Performance. The work that led to this report and the presentation was NCHRP Project 1433, the title John just said it a second ago. And before I go any further, I do want to acknowledge the remainder of the project team, which included James Bryce, now with Marshall University, Gary Higgs and Dingxing Cheng under Higgs LLC, and Beth Byzantine, who works in the same company as I do. In this presentation, I'm going to spend the first few minutes covering some important project background information. I will then move on to the project findings, which is where the bulk of the time will be spent, covering the recommended performance measures, but especially the models that were developed to capture the effects of preservation. At the end of the presentation, I'll spend a few more minutes summarizing some of the major findings, as well as talking about how those findings have been used in a couple of other projects. Moving on to the background information. For the purposes of this project, preservation was defined as a set of activities intended to maintain or to improve the functional, not the structural, the functional condition of pavements at a relatively low cost and while the pavements were still in good condition. What you're looking at on this particular slide, but it is intended to illustrate the two possible effects of preservation on pavement performance. The x-axis is pavement age in years, the y-axis is condition, but be careful because this is condition for a measure that increases or worsens with time. So excellent is at the bottom, very poor is at the top. So this would be things like rotting, cracking, IRI, and so on. The dashed line in this figure is the performance, or represents the performance curve for an untreated pavement. The solid line represents the performance curve for a pavement that is treated, the same pavement, but treated, the treatment taking place at H right on top of M in pavement. So if you look at these lines, and going back to the two possible effects, the first one is the immediate change in condition, or the initial condition jump, sometimes referred to, which is shown by that vertical line right on top of pavement. A thin overlay, for example, is very likely to reduce, perhaps significantly, or perhaps even eliminate rotting. Chip seal, on the other hand, is unlikely to have much of, if any, effect on rotting. So in the case of chip seal, the condition would remain where the dashed line is. So that's the first effect, and I'll go back to this a whole bunch throughout the presentation. The second effect, the second possible effect, is the long-term impact of preservation on performance. And this is illustrated by the shaded area that is contained between the treated, the solid line, the untreated, the dashed line, and the threshold condition. In essence, this represents the performance gain or the benefit of preservation. So this is good. Now, so those are two effects, the immediate condition change, so the long-term performance change. Going to the threshold condition for a second, that's the red line, horizontal line towards the top. This is basically, it represents the condition beyond which agencies will no longer consider preservation. The reason I'm going back to it is in the study we used it to define service life extension. It was basically the difference in pavement ages between the treated, well, the intersection between the treated and the untreated, and that defined the service life resulting from the preservation treatment. Now, with all of this in mind, The objectives of NCHRP Project 1433 were first to identify or to develop performance measures that capture the effects of preservation on performance and therefore on service life and life cycle cost. And number two, to develop guidance to facilitate the implementation of those performance measures. Moving on to the project findings, the first major effort in the project consisted of an information gathering effort, which in turn included a literature review as well as a survey of highway agencies. The purpose of the literature review, the first objective, there was a second one that I'll get to in a minute or two, was to try to identify as many potential candidate performance measures as possible. We were able to find at the time, this was about 3 years ago, 40 plus performance measures. We grouped them into the 4 categories that you're looking at here. Individual distresses, condition, self-explanatory, basically metrics that, whether it's cracking, rotting, faulting, IRI. The second group was composite pavement measures, and these were basically or mostly indices that incorporated 2 or more of the individual metrics in most cases. Examples would include payment condition index, payment condition rating, payment quality index. There's a whole host of composite indices, measures out there. The third category was the cost-based performance measures. Again, self-explanatory. Examples would include the equivalent uniform annual cost or the equivalent single axle load efficiency factor used by the Washington State DOT. And the fourth category was basically anything that didn't fall into the first 3. Examples include risk, the remaining service interval, concept, asset sustainability ratio, etc. So that was the first objective of the literature review. Moving on to the survey of highway agencies. Here we were trying to gather a little bit more information into the agency practices, not only the types of treatments that they were using, etc., but also if or not they were using any sorts of measures. And the second objective of the survey was to basically get a feeling whether the agency was willing to support the project by providing data. In this particular slide here, well, let me back up a second. We received responses from 33 of the 50 state DOTs, as well as highway agencies from 9 of the 13 Canadian provinces and territories. So pretty good response rate, close to 70%. What you're looking at in this particular slide is common treatments used by the highway agencies. At the top, we have asphalt concrete surface pavement, and you will notice that by far the more common treatments, or at least 2 years ago, were thin overlays, chip seals, and microsurfacings. If you move to the bottom, you're looking at the Portland cement concrete surface pavement. The more common treatments were diamond grinding with or without dial bar retrofit, partial or full depth patching, and joint sealing. And we did use these results, as you'll see later in the presentation. Now, going back to the literature review for 1 second, a second objective was to try to find a good definition of what a payment performance measure was. We did find several definitions. Many of those definitions had a theme in common. So rather than adopting a particular one, we formulated our own definition, which is summarized here. Basically, performance measures as used in the study were metrics that quantify the degree of achievement towards specific agency goals. In addition, or adding to that definition, metrics must be able to capture current conditions as well as the effects of agency actions, meaning do nothing, preservation, whatever, on the future condition of payments. Having established that definition and having the information from the literature review and the surveys in hand, 4 performance measures were recommended. Again, they're listed here: IRI, cracking, rotting, and faulting. Why did we recommend these? Number one, they met the intent of the definition that is at the top. We actually went through some preliminary validation using data from the LTPP program, as well as from what was available in the literature. That was number one. Number two, I believe these are metrics that are used by most highway agencies in their maintenance decision-making process. Number three, I believe every state DOT now has have as a requirement the collection of these data elements as part of HPMS, as part of the final payment rulemaking, as part of the legislation. So we've recommended this measure. So the next step is to really truly validate those measures. So how did we do this? We began by gathering data. There were 8 agencies that were very kind. They were kind enough to share their data with us. 6 of those agencies provided data for asphalt concrete surface pavements. If memory serves me correct, Texas, Virginia, Maryland, Ohio, Idaho, and Utah. 2 agencies provided data on Portland cement concrete surface pavements. They were Georgia and Washington State DOT. And of course, we had also access to the LTPP data, of which there was quite a bit. Now, going back to one of the early slides in the presentation, there were 2 effects that we were trying to model as part of this validation: the immediate effect of preservation, the long-term effect of preservation. We felt that if we could model those, in essence, we were validating the performance measures. Now, over the next few slides, I'm going to present examples of some of the results that we obtained in the project. They will be limited, at least this part, to the effect of thin overlays on IRI and rotting. Starting with the immediate change in condition, if you look to the left over here, the very first star represents, it's labeled initial condition, which perhaps could have had a better label. This represents the condition of the pavement prior to application of the preservation treatment. If you go to the next one, there's a drop almost to the x-axis. That's the second point. I should have said, what you're looking at here is condition versus time, y, x. If you look at the second star, there's a huge drop. That's, in essence, the difference between those two is what we define as the immediate change. The preservation took place somewhere in between those two. We basically did this. I'm sorry, I forgot to mention something. The sorts of data that we got from the agencies included construction history, traffic, but above all, it included performance data. Lots and lots of performance data. And the reason I remember this, that's what we're looking at here. We're looking at the condition right prior to the treatment and the performance afterwards. So in any case, this represents a single pavement segment. We did that for every segment within a population, where our population is defined by the combination of treatment, thin overlay, for example, and measure, whether it's rotting, IRI, or etc. So we did that, and this next slide is an example of the results that we obtained. There are 3 plots here. The one at the top represents the immediate change in IRI from a thin overlay. The one in the middle is for the Virginia DOT. The one at the bottom is for the Ohio DOT, or based on data from those agencies. Now I'm going to start with the one at the bottom. I don't know if you can tell very well, but right on top of the value, x-axis represents condition prior to the treatment, y-axis represents the immediate change in condition. So if you look right on top of 200, you'll notice there's a point that is circled. That is a point that was an outlier. We verified that it was an outlier. If we kept that point in the analysis, you ended up getting a horizontal line just about 0, meaning there's no change as a result of the thin overlay on IRI. We really did not throw away data. There were very few data outliers that we eliminated. We prefer to explore analysis techniques for other cases. But anyways, the point I'm trying to get to is if once we remove that point, if you compare the immediate change in condition versus the condition prior to the treatment for Ohio and Virginia, you will notice that they are almost identical. You probably cannot see from the back, but the A1, the coefficient right before IRI is 0.56 for Virginia, 0.53 for Ohio. The minus term is 33.29 for Virginia, 36.91 for Ohio. So that's really, really good. I mean, that's incredible. So we have an excellent correlation between what the condition was prior to the overlay and afterwards. LTPP is not quite that good, but if you look at pick up, for example, 150, 200 IRI prior to and see what happens afterward, you'll see that they're very close correlations. So we were quite happy with this. Later on in the presentation, I'm going to show the effects of thin overlays on rotting, which I found that to be an interesting example. In any case, moving to the second effect, the long-term effect, what we did, there were a number of approaches that we could have taken here, whether using the absolute difference between the performance of a treated and untreated pavement, etc. In the end, what we decided to pursue, the goal of this project was not model development, it was validation of performance measures. That being the case, what we decided was let's compare for the long term the growth rates for treated and untreated pavements and see if there's a difference. So this is really what you're looking here on the left. We ran for every pavement segment, for every combination of treatment and measure. We ran a regression line. So that was lots of regressions. In this example, there are 3. And once we had that data in hand, there were a number of analyses that we conducted. To the right, there's the long term is the growth rate as a function of condition prior to the treatment. That was one of the analyses that we performed, and I'll illustrate it in a second. But the basis for the analysis that we did for long term is the left side here, regression lines with the growth rate for treated and untreated pavements. Now, here what you're looking at is exactly that. Growth rate for the untreated test sections, that's the x-axis, versus growth rate for the treated ones on the y-axis. Now, I know it's kind of hard to tell, I don't think anybody can, but there's a little bit more circles under the curve than there is on top of the curve. That means basically that the growth rate for the untreated pavement is a little bit larger than that for the treated pavement. And we actually ran regression statistical analysis, and the values that you're looking at is what we got there. Not much of a difference, very small numbers, but it was statistically significant. So that was one sort of analysis that we did. The second one, we wanted to look at, okay, how did the rut growth change as a function of the condition of the pavement prior to application of the treatment? There's a lot of scatter on this plot. There's points all over the place, but there's clearly a positive slope to the regression. And I think, well, it's 0.02, meaning 0.02 inches per year on that one. We actually did take it one step further. Okay, what if we start considering some of the non-conditioned factors? Non-conditioned factors meaning the pavement structure, traffic, subgrade, climate. Can we develop rut growth models that make sense? What you're looking at here on the x-axis is rut growth predicted from the models. The y-axis is rut growth measured, actual. And if you look at the regression where the points fall in that line, the red pluses represent untreated the circles represent treated. If you notice, they fall really close to the line of equality, which means that we can develop indeed very good models that will give us the performance, the long-term performance of treated and untreated pavements. That basically, at that point, the study 1433 ended, and I'll get back to it in just a second, but I did want to very quickly bring another study, a follow-up that got started as 1433 was finishing, 1438 commenced. 1438 was about providing guidance for the timing of preservation treatment for asphalt concrete pavements. So in this example, we had the data from 1433. The same agency that provided those data were kind enough to give us permission for this new project and provided 2 more years worth of data. In addition, we had Tennessee, Maine, and Louisiana also provide data. And we had LTPP data. So we had quite a bit of data. And here, because what we were trying to address was the timing issue, then modeling was important. Why? Because timing issue basically comes down at finding the best compromise within cost and benefit. If you're trying to define benefit, overwhelmingly, it is defined in terms of performance. So performance models become very important. In this project, we basically developed performance models for the various combinations of treatments on the first column versus measures at the headings, the different headings. And these are all based on the previous project from NCHRP 1433. I'll just give you 2 more quick examples. This happens to be the immediate effect of thin overlays on rotting, and I found this to be quite interesting. It's a quite good correlation, but if you pick any value you want on the x-axis, which is rotting prior to the overlay, if you pick 0.5, go up to the blue line, which is the regression, you'll see that it decreases by 0.4. This is not the rotting after treatment, but how much it decreases after treatment by. So if you pick up 0.5, it decreases by 0.4, which gives you remaining rotting of 0.1. If you pick 0.2 prior to treatment, you go to the blue line, you get 0.1. All I'm trying to say is the effect, another way I could have presented this, it doesn't matter what the condition of the pavement prior to the treatment, for some reason it always ends up in 0.1 inches after application of the treatment. This is using the same data that you saw previously for LTPP, Virginia, and Ohio DOT. So I thought it was quite an interesting result. On this one, we did develop models. I haven't put the model here because it's really long. It includes all of the variables that you're looking at here. You'll notice that there are condition elements in there. That would be the IRI before the chip seal. This happens to be a chip seal. There are climate, there are pavement structure. The things that you would expect that affect performance are reflected in the model that was developed. This happens to be a tornado plot that gives you an indication of how significant each of those variables was, and they've been ranked from top to bottom. So here is a plot of measured versus predicted. And again, it's not perfect, but it is good. There's a very definite correlation. We felt quite happy with it. Almost the end of the presentation. NCHRP report 858 was, as I just said at the start, published last week, or at least released last week. One of the things that the report includes as an attachment, a guide for how to select your own performance measures or use the measures that were recommended in the report, as well as how to implement them, beginning with the sorts of data that you need, how do you prepare those data, how do you develop the models, and how do you implement it within a pavement management system. In terms of some of the major conclusions, we were quite happy that the data exists out there for developing performance measures. There may be combinations where perhaps not as much as we would like, but the data are out there. Agencies are collecting it, and if it's not available, there's always national resources that can perhaps be used to help out. Quality of the data, I think I've heard it a couple of times this afternoon, certainly important. One of the things that I perhaps may not be happy to hear, but There are techniques out there that can help us to develop the models that perhaps are not used on a day-to-day basis in the pavement engineering world, but that perhaps we should be considering and implementing. There's good stuff out there that can help us out. I covered this project already. This was 1438, and I gave a couple of examples. The last thing, and there's 2 slides on here, one of the projects where the findings are being used is in federal highway pavement preservation, where there are 3 reports being developed. 2 of them are just about to be released, the first 2. The first one is basically how to select measures, metrics, triggers, and thresholds. The other one is how to adopt, or how to incorporate preservation into strategic level decisions. Both of these are just about published. They're important, the connection to 1433 is, in both of them, there is a literature review and a synthesis of information, what's out there in terms of those 2 topics. There's also recommendations on what should agencies consider. And there are case scenarios in all of them to help out in the implementation of the concepts that are contained in those documents. There is a 3rd document that is being worked on right now that's still probably a month and a half, 2 months from being available. The same thing with a pavement preservation analysis tool. Same project. There were 3 peer exchanges. The report should be out in a pretty much a matter of days. There's going to be a webinar. It says here March 27th, a 2-hour webinar that Federal Highways is sponsoring on those 3 reports that I showed in the previous slide. I have the feeling, I think this got moved to March 20th. Anyways, there's a webinar in March on those 3 topics. And the last thing is 4 workshops. Jason, I don't know, I think Jason left already. Jason, I believe, is working with the different partnerships to try to schedule like 4 hours to address the topics. I think he may be having second thoughts about too much time, etc. But anyways, it's something that is part of the project, workshops on those 3 topics.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.